Hello wonderful person, this is Anton, and in this video we're going to be talking about a very fascinating topic of Quasar Tsunamis. And that does sound like something extremely powerful and extremely dangerous. But let's discuss what exactly it means for various galaxies, and welcome to What the Math. So honestly, quasars are always fun to talk about, mostly because they're still quite mysterious. Because from I guess a few decades ago when we originally saw them as these really bright stars and we couldn't really figure out what they were, to the discovery that they're extremely powerful and extremely massive galaxies, which a lot of scientists didn't even believe at first, to then discovering that a lot of this power comes from these ultra-massive black holes in the middle that are absorbing so much mass that they produce a tremendous amount of energy and essentially this blinding light that creates brightness that's brighter than approximately 1,000 galaxies combined together. While at the same time, with so many different quasars out there, we're always kind of fascinated about different connections between them, what they actually represent for the evolution of the universe itself, and the more important question here is in regards to how this evolution of galaxies may have influenced our own galaxy as well. So in other words, has our own Milky Way been a quasar at some point in the past, and what did this do to our galaxy? And as we learn more about them by looking around the universe and discovering more of these quasars and the interaction they have with the galaxy itself where they reside, we realize how extremely powerful these events or these things, these objects are, and how they actually do influence not just the galaxy where they reside, but everything around them as well. Not to mention, we've also been discovering all sorts of connections between the, for example, galactic web or cosmic web and the position of quasars across the universe. So there's definitely a lot of really interesting things when it comes to quasars. It's one of the most fascinating studies in cosmology. But this recent paper that came out only a few weeks ago talks about something else that we kind of expected, but never really to that extent. And specifically here we're talking about what's known as a quasar tsunami. And as you can probably imagine, just as scary as it sounds, it's something extremely powerful and something that does influence the entire galaxy dramatically. Now quickly in a nutshell, so a quasar is essentially an extremely hungry galaxy, or technically galactic nucleus. The center of this galaxy usually possesses an extremely powerful black hole that starts eating up so much matter that it essentially just explodes with energy. It starts producing so much energy that it generates these really powerful winds that influence the rest of the galaxy as it keeps absorbing more and more matter. But as the matter falls into the black hole and generates a lot of this energy that's then exposed, this so-called galactic wind, or I guess you can call it quasar wind, becomes so powerful that it actually starts to influence the rest of the galaxy, in most cases causing a lot of the star formation to completely stop. Now this is something we kind of expected, but the recent paper used Hubble telescope to analyze 13 different quasars and discovered that some of these quasars are so powerful that they go beyond disabling stars. They create conditions that are essentially really extreme. For example, they generate such powerful winds that the material from within the center starts moving at approximately 6% of the speed of light and moves across the galaxy, colliding with everything on the way, first generating a lot of X-rays and a lot of ionizing UV radiation, essentially radiation that would probably strip any planet of atmosphere, and then slowly transforms into visible light and even infrared light. So essentially it creates this kind of a firework of different frequencies that are visible from really, really far away, and all of this is huge. It's the size of a whole galaxy. It's at least several thousand light years across. So it's almost the size of some of the smaller galaxies. They've also witnessed one of the quasars exhibiting a tremendous increase in energy that actually accelerated the wind by about 6 to 7%. So essentially it was moving at about 6% of the speed of light, and then the speed of this wind increased by about 3 million miles per hour, or about 4.5 million kilometers per hour. All of this within relatively short time frame. So this is something that we really didn't expect to see. This is how extremely powerful quasars and these active galactic nuclei are in general. So they do produce tremendous amounts of energy that influence the rest of the galaxy. And so by observing different quasars, they've established that there were a lot of different effects here. a lot of really strong and powerful winds, essentially causing the entire galaxy to kind of expand and inflate in some sense. And this is literally why the scientists behind this paper called this a Quasar Tsunami. It was a huge wave of really powerful, extremely high in energy material that was moving across the entire galaxy, slowly pushing everything aside, slowly destroying everything on its way, or at least influencing a lot of these stars in such a way that no new star could be produced, and very likely a lot of planets would probably be completely stripped of everything. And it seems that a single quasar, similar to the ones they've looked at, usually can easily push out approximately several hundreds masses of the Sun every single year, and a lot of this mass ends up being in the intergalactic space. Now, some of it might actually eventually come back to the galaxy, which is what we believe happens in most cases. In other words, some of this gas will kind of move away and then slowly get attracted back to the galaxy and then re-enter and possibly create new stars afterwards. But some of this gas might also end up in the intergalactic web, in the cosmic web, and be trapped there forever. So we're not really sure how all of this really influences galaxies, but it does explain why we don't usually see large massive galaxies as often as we would like. We do see a lot of smaller galaxies, and in most cases there is actually a correlation between the mass of the central black hole and the size of the galaxy. So what this all means is that the actual black hole in the middle controls the size of the galaxy. It actually prevents certain galaxies from growing too large, and also prevents some galaxies from having too many stars. And the more active the black hole becomes, the larger it gets, the more likely the galaxy is not really going to possess too many stars and too much mass. Most of it will probably get expelled. At the same time, this also explains why in most cases we see that star formation happens in bursts and usually around the same time. Like for example in the Milky Way, we know that these bursts created most of the stars. The vast majority of other stars, there were only very few stars that were created in the Milky Way galaxy in between these bursts. Now, we think our Sun was actually also produced during such bursts, but for the most part, we never really understood what's really stopping these bursts from happening more frequently. And these scientists and a lot of other scientists suggest that it's actually the active galactic nuclei. Now, we don't think our Milky Way has ever really been a powerful quasar, but we do know that there were a few cases or a few times when our galaxy did experience the active galactic nuclei bursts. More specifically, not so long ago we've discovered these so-called Fermi bubbles, which seem to be the leftovers from one such experience when the black hole in the middle of our galaxy started absorbing a lot of mass and created these really large and powerful emissions. Now, it may have not really been a true quasar, or at least not a quasar that would be really bright as some of the ones we've just observed, but it might have been enough for it to kind of look like this, like a typical quasar from a distance, while at the same time, it did probably stop a lot of the star formation in the galaxy for at least some time. But we haven't really experienced any major bursts since then, and this was probably a few million years ago. So we don't really know what causes these bursts to occur afterwards. This is yet another mystery of the universe. Or we don't actually know what causes stars to suddenly start forming in between these galactic bursts. Or we don't actually know or currently understand what causes sudden bursts of star formation in between these very powerful galactic bursts caused by black holes. But it is something we would really like to learn more about, because technically, if such an event occurs in the Milky Way galaxy, there is a really high chance it's not really going to make our Earth any more habitable. So these events are really important for us to understand and for us to actually learn about, especially because in the last few years we've discovered that our own black hole in the middle of our galaxy seems to be getting a little bit hungrier. It's been increasing in brightness over the past few years, and we can't really explain why just yet. So we're secretly hoping that this is not the beginning of some sort of a major quasar event or any other event that could potentially cause problems for humanity. Although currently we don't really think that anything like this is going to happen anytime soon. There are just no signs or no evidence to suggest that our galaxy is going to become a quasar anytime soon. But this doesn't mean that we should stop learning about quasars. This nevertheless is a very fascinating topic and does teach us a lot more about the universe in general. But anyway, on that note, that's really all I wanted to mention in this video. You can check out the paper I mentioned in the description below, and subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something you may have not known before, and maybe support this channel on Patreon. This does help me quite a lot. Alternatively, you can also support this channel by buying the beautiful, wonderful person t-shirt that you can find in the description below. I'll see you tomorrow. Space out, and as always, bye bye.